1 through 25, and do we just do that 25 times?
Yeah.
And then
I know it's nasty. Don't expect me to ask you that question on the exam.
Okay.
On the exam, because I don't want to cry when I grade your exams, I'm not going to ask you to subdivide an interval in 25 subintervals.
And
I'll do something like subdivide 6 or 8, something that's manageable, that's not going to take you a half hour just to compute with your scientific calculator.
okay, and then the second part of the problem was 2n, which ended up being 50 subdivisions. And I typed it into my calculator and somehow still getting the wrong answer. I don't know if I was using the sum.
The summation symbol.
Exactly. And I didn't know if I was supposed to. I started at 1/25, because that was delta x, and then I ended at 24 over 25,
And that was your last tick?
no, that was my last tick for the middle part, for the 1/2.
I see. Okay, good. So you did take it one step further, which you should have. Yeah.
And I couldn't get the right answer.
Maybe for that question, because it's a calculator issue question, maybe I should sit down with you like after class and just make sure that we're just kind of putting in the right data. Do you mind if I do that?
Yeah.
Would that be okay? Yes.
How do you find our number 31? How do you find the errors? Because I kept getting the wrong answer.
31?
Yeah.
I don't know. I have to read it. So we're using both the trapezoidal rule, Simpson's rule, and compute the absolute errors with both the trapezoidal rule and Simpson's rule.
I couldn't even get trapezoidal, so I didn't nail on the Simpsons.
Oh, I wish mine had left it in here. What's number 31?
To the 2x. Yeah.
Are you guys okay with my version of the error formulas as opposed to the way the author writes them?
Yeah.
I mean, they're really equivalent, aren't they? So we have the error using the trapezoidal rule with n subdivisions is bounded above by, does anybody remember? K times raised to the third, but all over
12
times n to the degree, where it is the case that k is an upper bound for the absolute value of f, shoot, what was that called? The third derivative? Excuse me, I misspoke. You're right, the second derivative. So you guys, let's take a break. Before I dive in and use this error formula, let me take a break and just find out what that value of k is. But look at my function. Its first derivative is 2e to the 2x. Second derivative is 4e to the 2x. And so I maintain that I'm just trying to find out for the second derivative function what the absolute value maxes out at over this particular interval. You guys, I'm a glass of it. It's 0 to 1, isn't it?
Yeah. Yes.
So over this interval, I don't know, you guys, just panic and say something about this function. Don't worry that it's a second derivative function. Just look at that function.
It has no zeros.
Yeah, I think it has no zeros. I think something more important, though, is that you guys can kick back in your chair and tell me whether or not it's strictly increasing or strictly decreasing. Clearly, it's
Decrease.
strictly increasing.
Increase.
It's always positive. So I think the largest value for the absolute value of the function's output is going to be clearly this function evaluated at the right endpoint. So I will choose k to be nothing more than, is that 4e squared?
Yep.
You guys, stall for a minute. Is that okay? Be honest. All right. Miriam? I want to go back. I want to say something real quick because it's too important. And besides, it's so easy if you look at it the right way. You know, this statement right here simply says this. You guys, don't worry about derivatives. Just treat the second derivative function as a whole new function. Call it g. And if I already graphed my function g, don't you guys agree it would look something like this? at least from 0 to 1. It's just an increasing exponential function. I'm a little off with my numbers, by the way, you guys, technically speaking. At x equals 1, y is not something like an easy 1. It's actually something different. It's actually this. And if x is equal to 0, I think the corresponding y value is, I don't know, is that 4? And because I got an exponential function for the second derivative function for f over this interval from 0 to 1 looking like this, that's clearly increasing, I think the largest y value in absolute value as this curve attains is simply this one right here, 4 times e squared. This one I'll choose to be my k value. So let me come back. I think the error, using the trapezoidal rule with how many subdivisions? Yeah, in the book he has 4. He has 4. He didn't. You know, with this question that you guys are answering the homework set, he actually asked to compute the absolute errors in the trapezoidal rule with 2 n subintervals. So if I'm going to do this directly, just directly with my formula, I would actually evaluate this. Which, by the way, is bounded above by my k value. I've lost it. 4e squared. Times my interval from 0 to 1 raised to the 3rd power. That's just this. I'll look at my 12 times n squared, but n is this. So, sir, when you said, I went through the formulas, I just didn't get the same answer the book did. Do you have the homework in front of you that you did? I mean, is this your value?
Yeah, that's what I plugged in.
See what I get.
So if we actually computed like 50 numbers, we did it wrong?
What do you mean by that?
So doing the trapezoidal rule, I actually expanded it.
But is that what he asked for?
That's what I got out of it. I mean, I don't know if I read it right.
So you know what? He's got some shortcuts.
Yeah.
I mean, if you go to page 497,
Yeah.
I mean, there is a shortcut for since we're using 2n subdivisions, but it still requires trapezoidal rule with 2n subdivisions.
Yeah.
However, you can also backtrack from that, and he's got another nifty formula. I can't remember where it was. On the bottom of 496, where you can interpret the trapezoidal rule in terms of midpoint rule, where t of 2n is equal to expression involving only n subdivisions. You could have cut it in half. Technically
Okay.
speaking, I think it's a lie. Because t of 2n in terms of t of n, here's what he has. I think. I can't remember this formula. Trapezoidal rule with 2n subdivisions is the average of, I think, the midpoint with n subdivisions, and the trapezoidal rule for n subdivisions, I think over 2. You guys, I'm stalling because I don't use these formulas. But I think that's it. You can double check me. So everybody, look, life is nice, isn't it? Now instead of doing 50, I can only do 20. I could just do 25. Do you guys agree?
What about for the one that has us do 100?
Okay, I'll do your one. If I'm going to use trapezoidal rule with 100 subdivisions, now I can interpret just using only 50 subdivisions in 50 computations. Come on, you guys wake up.
Of each? That's 2/3, that's 100.
I know. It doesn't work. It's not a shortcut in that sense. Do you see, Bradley, what I'm pointing out?
Yeah.
Because with the trapezoidal rule, you're looking at the endpoints of each of the subintervals, but cheapers. Now with the midpoint rule, I'm choosing the midpoint of each of the subdivisions. It doesn't save me any steps in terms of computations.
All right.
Get the idea?
Yeah. So it's a miserable equation to cut.
Yeah, that's what I'm saying. In a test
All right.
situation, I don't want to go home and grade that.
Can you explain why you're doing 50 instead of n equals 25?
Because that's what he asked. He said, take a look at this interval with this many subdivisions and compute the error with the trapezoidal rule using twice that many subdivisions.
Didn't he say n and 2n?
Oh, did he
No,
really?
that was an A,
That was an A?
not the C.
No, okay.
Yeah, but in part C, he's asking me to
Okay.
compute the error using twice that many subdivisions.
So can you do the math on that?
Yeah, I'm so sorry, sir. I started, but I just didn't finish. Let me show you what I come up with and tell me if you disagree.
Yeah, it said that was not the right answer.
What did he come up with?
4.26 times 10
Sorry, I'm just checking my digits real quick. Sir?
Well, this is where same question from yesterday. It says absolute error. So I evaluated the integral absolute value of c minus x. I thought was the absolute error.
Do you know what? Looking at his English, I think that's exactly what he's asking. When I read it, I was thinking, come up with an upper bound for the error in using trapezoidal rule. But he's actually asking to compute the absolute errors. So what he really wants you to do is this. He wants you to evaluate this interval and come with some number, call it question mark. Now somewhere else in this exercise, he asked for us to actually use the trapezoidal rule, I think, in part A, with n and 2n subintervals. So, in evaluating t at 2n, I come up with some number called question, or excuse me, pound symbol. Now in number 31, if I read the instructions carefully in part C, he's asking me to compute the absolute error in using 2n subdivisions. So what he's really asking for is this, the difference between this number and this number. Oh shoot, you know what? That might be negative. So, let's compute the absolute value of the difference. I answered a completely different question. When I did all my work over here, I just simply read quickly, and I read I should find an upper bound for the error. And so I went through my formula. That's what I come up with.
Why is
Thank
it so
you.
different? Why is this like
Ooh,
so
okay.
far off?
Here's why it's so different.
You have 25 subdivisions.
Let's not talk integrals. Let's not talk Cartesian plane. Let's talk about the real number line. And let's just talk numbers. The evaluation of the integral is equal to question mark. It's just that when you compute t of 2n and you find out this number pound symbol, I think it's really just nothing more than going in one direction or the other direction. And they get a whole range. Now, the true value is somewhere between this tick and this tick, and the true value is going to have an absolute value difference being this number right here. It's just that when it comes to the error formula over here, this number is about twice as big as this one for the following reason. From here to here, I can guess a value of the base, could say something like this. But if the true value is way over here, I get a much bigger difference. It's really because this thing right here is acting like your delta with your epsilon delta definition limits. And so I'm deviating from the actual value to the right or to the left by delta units. But this number over here simply gives me the broad range about that particular true value for which I might have that true value. There's a difference. Do you see it? Ooh, you guys don't like that. Pick the number 3. And I want you guys to deviate to the right or to the left by 1/2 unit. Where are you going to be?
3.5?
1/2 units.
Oh, 1.5. 4.5.
So 4.5 or 1.5. Now close your eyes and pick a number in here. If you close your eyes and pick a number in here, you get really extreme, like, how about this purple number right here? Now pick another number in this interval, and let's be really extreme. Let's pick one to the right over here. What's the upper bound for the difference between these two positions if these two numbers are somewhere between 1.5 and 4.5? All right, listen to my choice of words again. It's
3.
important. I agree with that. I think no matter what two numbers I choose from 1.5 to 4.5, their difference could be no more than twice this deviation. It'll be no more than, in this particular example, 3 units. And that's exactly what this number right here represents. It's sort of like the horizontal length of that one full interval over which I might have my values. Whereas this difference right here is really saying, well, this is the actual number that's the evaluation of my integral. And I'll deviate to the right or to the left by a certain number of units, that's my delta. And so I think this absolute value difference is acting as a delta, not as the entire range of that particular interval. There's a difference. That's why mine seems to be roughly twice as much as his value. But again, I just read the question quickly, I didn't read it correctly. He was asking for a much simpler process.
The c minus x, is that the formula that he uses? Is that the formula that is necessarily something that we will use as well?
I don't know, does he use C's and X's?
I don't know what he does.
Yeah, he uses C.
Okay, so I used
There's-
pound symbol and question mark. I don't care what you call them, doesn't make any
Okay.
difference. can I just say this? What would be the point of me asking that question on the exam? If you use a trapezoidal rule, get an approximation, you evaluate the integral, I think you guys understand that the absolute value difference is just the absolute value of that difference. It's not a significant question. I think a much more interesting question is this. Given the integral, let me not tell you how many subdivisions you must create. You tell me how many subintervals you must create in order to get some kind of desired accuracy using Simpson's rule or trapezoidal rule or the midpoint rule. Don't you think that would be a much more pertinent question? You don't seem to agree with me. I hope you do.
And just solve that like part 3 of the quiz.
Yeah,
Okay.
and I promise you, I've got some extra questions written. I just
Okay.
ran out of time yesterday to post them. If I'm answering your question, anything else? Yes.
So when the book or you on a quiz exam asks the question mark, the integral, so we're supposed to calculate that using the techniques we learned previously.
Somebody's phone.
Oh, is it a phone?
Yeah, that's a ringtone.
Sorry, I was worried it was a siren going off for a while.
It's a lot louder.
Fire
Maybe
drill
completely
ringtone.
dropped the track of my thought. I'm sorry. Can you answer the again?
So on the board you have the question mark, which was
Turn mine down.
Oh, I guess I forgot mine.
the question mark is evaluate the integral. So
Yes.
we're supposed to use the techniques we learned previously.
Yes.
Okay.
Yeah, I
not
agree.
Okay.
In English, I'll make it clear. If I'm not clear in English on the exam or quiz, you just come up and ask. I can clarify it. Well, are we ready to have you show me you know your stuff?
Can you leave all this on the board?